Okay, so in this one, I'm going to answer this last question, which is at what times is the ball at an elevation of 42 meters? Now, if it goes all the way up, if the ball is popped up to 63 meters, okay, I think it's going to be at 42 meters at two different times. Once on the way up, right, and then one time on the way down, okay? And a considerable amount of time is going to separate those times, right? So let's just see what we can do here. Okay, I think what we have to do is go from this point to 42 meters, okay? So let's set that up. X, VI, VF, A, and T. Okay, so X is obviously, our displacement is positive 42. Our initial velocity I'm going to use from the previous problem. Now, it's not even one of these answers, but in the previous video, I had to solve for the initial velocity, and that's 35.14. Okay, and then the final velocity is what we're actually going to solve for this and use that to find the time. Okay, this is negative 9.8, and this is what we'd like to find. Okay, now what I'm going to do is I'm going to use, and I think I'd better divide the screen up here, right? Okay. I'm going to solve for the time down here. This will be like on the way up, on the way down, but let's figure out the final velocity here, right? So to do that, I'm going to use this guy. Now, to be sure, by the way, I could use this formula. X is VIT plus 1/2 AT squared. You mathematicians out there, plug it in. You've got X, you've got VI, right? You've got A. The only thing you don't have is T. It will be quadratic. You'll get two positive roots for this, and they will be this and this, right? So negative b plus or minus the square root of b squared minus 4ac over 2a or something like that, right? You have to do the quadratic equation. I'm not sure I got that right. Okay, and you would get this as the two roots, the two values. I'm going to show you how to do it without doing that. Okay, so I'm going to choose this guy, vf squared is vi squared plus 2ax. Right, so then that is VF squared equals, well, 35.14 squared. I'm using the initial velocity, right? Plus 2 times negative 9.8 times 42. Right, so I'm going to take the square root of this, right, and the square root of this, which will get rid of that, right? So I go square root of 35.14 squared plus 2 times negative 9.8 times 42, right parenthesis. Now I get that the final velocity is positive 20.288 meters per second or negative 20.288 meters per second. Now, of course, the positive is on the way up. The negative will be on the way down. Okay. Now, it doesn't ask for the velocities at an elevation of 42 meters. It asks for the times. So for the time going up, I'm going to use this guy. VF is VI plus AT. Right. Our final velocity is 20.288 equals 35.14 plus negative 9.8 times t, right? Okay, so I'm going to go 35, wait, hold on, clear. 20.288, and then I subtract this guy, minus 35.14, and then divide that by negative 9.8, and I get 1.5155. Right, so that's the 1.52 seconds, and that's for going up, right? For the time going down, we do this exactly the same formula. So VF is equal to VI plus AT. Okay, and now the only difference is that now it's this negative 20.288, right? Now you might think mathematically that you'll get the same answer, but you're wrong. 35.14 plus negative 9.8 times t. Okay, you're wrong because now when I subtract the 35.14, right, it actually becomes a big negative number over here. So I've got negative 20.288 minus 35.14. And that's like negative 55.428, right? Equals negative 9.81, or 9.8, right, times t. So now I can divide that by negative 9.8, and I get 5. T is 5.6559, right? So 5.66 seconds, right? And that's the time for going down, okay? Now, you could have done this all using this. You could have done the quadratic equation with this. I just wimped out. I did it this way. If you look, though, we're doing, this looks a whole lot like b squared minus 4ac or something like that, right? So it looks like we're doing some of the same math. It just makes more sense to me this way. I don't think it's any less work or more work.